Hey, welcome to Almost Impossible. Our second episode is about the Wright Brothers and the invention of flight. I'm Craig Cannon, one of your hosts. I'll be joined by my co-host, Tim Hwang, in just a second. And we'd like to thank Buskirk for helping us research and tell this story. We'd also like to thank Protocol Labs Ventures for making this show possible. PL Ventures invests in companies across Web3, as well as those building on the PL stack, which includes IPFS, Filecoin, and libp2p. They also invest in companies working on breakthroughs in computing, like brain-computer interfaces. If you're a founder looking to raise a round in one of these areas, you can email funding@protocol.ai.
One of the things that I think about when I think about big leaps in progress is big projects, right? Big brains, big organizations, big funding. One of the reasons that we ended up doing the Manhattan Project was that it was kind of like the 5-year-old version of, what big leaps in progress look like, right? A huge secret project, huge amounts of funding. But today we're going to do something totally different. Mm-hmm. Yeah, we're going to focus on the Wright Brothers and the invention of manned flight. And this is really, I think, a fun topic in a lot of ways, just because it's so different from, the Manhattan Project, but also it violates a lot of our assumptions of like how innovation happens. And so it ends up being a super, super interesting story with like a lot of funny stories in it, right? Like there's the Wright brothers who are like real characters. There's the history of people trying to fly and failing, which is amazing. And I think there's just a kind of fascinating dynamics of, how do you get, the invention of a totally new category of transportation to happen?
And honestly, my opinion before we started doing all this research was like, I'm not sure how much I care about the Wright brothers.
I think I remember you were like not that into it. I pitched it originally.
Yeah, I'm just imagining like these old black and white videos and kind of those like caps that they would wear. And all just feels like, obviously the invention of flight is super important, but it didn't feel like that kind of bleeding edge feeling of innovation. But I think what ends up coming out in this story is these guys are like inventors in almost like it feels like a contemporary Silicon Valley kind of sense. Mm-hmm. And so it's cool to just see like how much they actually built amidst all of these like titans of industry and competition. And it is a real cool story.
And that's actually a great place to start. One of the examples that I found most interesting is this whole project that the Smithsonian was involved in the early part of the 20th century. So there's this guy, Sam Langley, who's basically like an astronomer. He's like the head secretary of the Smithsonian. He's like essentially like one of the most respected scientists in the US. Yeah. And he basically has a dream of doing manned flight. And so the Smithsonian funds him and the War Department funds him. It's like a big project. And there's this great scene where, he's basically trying to demo this device that he calls Aerodrome A on the banks of the Potomac River. And like the reporters are there and like all of his government backers are there. And it's this really big sort of project. And, Craig, you were telling me about this originally, like things go totally wrong.
Langley wasn't a complete crank, right? So he had so it was called Aerodrome A, but he had prior aerodromes that were unmanned gliders. So you can kind of imagine they were propelled via many hilarious different methods, one of which was rubber bands. So it's essentially like wound up rubber bands, like a kid's toy that generates the energy for the propeller. But this was the big manned flight experiment that he was going to embark on. And so he had funding from the government. Actually, Teddy Roosevelt, who I think at the time was the Secretary of the Navy, was excited about it, and he helped fund it. And there they were demoing on the Potomac River. Langley wasn't a pilot, interestingly, like actually an important contrast in this story to the Wright brothers, who were always flying their own planes. So he launches it from the top of a houseboat. It's a catapult. It flies about something like 60 feet before immediately crashing into the river and then nearly drowning the pilot.
Yeah, the pilot needs to be like hauled out of the river, basically. It's actually kind of like, it's pretty dangerous what they're doing.
It's incredibly dangerous what they're doing. And it's an interesting example of the time, like we're going to see it in this story, of how folks essentially just tried to like scale up models of their like little demos, and they weren't working because they really didn't understand the science at the time. They were just sort of guessing. And as Tim said, like this is the coolest contrast, because this is like the mega funded government moonshot project that's totally failing. And then within 9 days, the Wright brothers fly.
Yeah, that's right. And I think that's why this kind of like the Aerodrome A case study is so good, right? Because it's like this huge high profile failure. Like the Washington Post devotes a whole op-ed to basically saying the government shouldn't be involved in this crazy flying thing. And yeah, you're totally right? Like 9 days later is like the famous Kitty Hawk series of flights that the Wright brothers do. And in contrast, it's like totally unrecognized at the time, right? Like I think it warrants like a tiny like throwaway mention in the local paper. And, you know, I think what's so interesting is looking back historically, right? Like Langley, I didn't know anything about, right?
Never heard
Like
of
he's
him.
basically forgotten historically. Like I think he spends the last few years of his life trying to raise money for like another test and kind of just dies a disgrace. And yeah, obviously we remember the Wright brothers. And so, you know, I think we're left with this great kind of like contrast, right? You got the Langley project, which costs $70,000, huge amounts of public funding and attention. And then you've got the Wright brothers, who I think all told do this entire project for like $1,000. And they receive no public funding. It's basically funded out of the proceeds from their bike shop. Yeah. And so it's like this totally weird contrast. And, you know, the big question ends up being in my mind, right? Like, how did the Wright brothers do it? Why were they successful when much bigger projects failed? How are they successful when so many people had failed before them? And I think those are kind of the key questions that like I want to talk about today.
But before we get started, I think we need to pause and talk about the fact that people have been wanting to and failing to fly throughout history. So there are some kind of amazing stories, the earliest of which mostly involve people creating a backpack wing. Usually these folks are kind of well-educated kind of monks and people working sort of in the clergy, sort of academics of the time, right? So they climb to the top of steeples or minarets. In the case of Abbas Furness, this guy who is totally legit, right? This guy invents like the process of making glass.
Yeah, I think he also invents like the metronome.
Totally.
Like no big deal, right? So
Yeah.
like, yeah.
He's totally legit, but still not quite the inventor of flight because he climbs to the top of a building and just like jumps off with this thing.
Which mind you does not work, actually. That's not a good strategy for flying.
Yeah, which is not what the Wright brothers end up doing. And then, similarly in England, there's a story about a monk doing this. He blames it on the fact that he didn't have his tail with him to fly, which I think was a serious comment. And then obviously we know about Da Vinci's drawings, which more resemble like helicopters and kind of like powered flight. Again, not successful. And then coming into the early 19th century, we have the creation of fixed wing gliders. So that kind of brings us to some of the more influential people for the Wright brothers, which we're going to talk about in a little bit. A guy named Otto Lilienthal in Germany, and many others just kind of experimenting with the early days of fixed wing gliders.
Yeah, and I think it's worth looking into some of the history here of early flight, because some of the ideas proposed are like, in retrospect, you look at them and they're like, it's clearly not going to work.
Yeah.
So one of my favorite is in the late 1800s, there was this idea that was submitted to the patent office for this device called the aerostat. And what the aerostat is basically, it's an enormous metal fish that flies through the sky. And the way it propels itself is through a series of explosions that come out the rear end of this thing. Didn't work. I believe it was ultimately kind of rejected. And so I think this is where we end up is, you know, the questions of how the Wright brothers were successful, like so many kind of problems where lots and lots of people try it and they fail, is actually kind of pretty complex story, right? It's a complex mix of luck, technological progress, and personalities.
All right. So again, I was wrong about the Wright brothers, and let's introduce them a little bit.
Yeah, for sure. So the Wright brothers, they're great. I fucking love these guys. It's just like the most heartwarming American story. So these two guys, they grow up in Dayton, Ohio in the 1870s.
Sort of like we talked about in episode 1 with Berkeley being completely different in the 20s to today. Same deal with Dayton, Ohio in the 1870s to today. It's a place of industry and innovation. It sounds like a joke, but the first mechanical cash register is invented in Dayton. The stat is that there are more patents per capita in Dayton than anywhere else in the U.S. It's kind of like a happening place.
Yeah, for sure. And keep your eye on that cash register thing because it comes back weirdly at the end of the story. So keep that in mind. The two of them, they grew up in an educated family. Their father is this guy, Milton Wright. He's a preacher. And their mother, Susan Wright, had grown up in a family that built carriages. So she turns out to be super mechanically inclined. She basically is building these toys and appliances for the family. And the Wright brothers actually end up consulting her in the early part of their work.
You know, a funny thing about their childhood, they had access to one of those rubber band toy planes. So it's actually invented in 1870, and the fancy name for the rubber band plane motor is called a torsion motor. By 1878, their dad bought them one in Ohio.
Yeah, and I think one of the brothers ends up crediting that with like an early inspiration for being excited about flight.
And it sounds really silly, but actually engineers and aeronautical designers use these to kind of like scale model ideas out. So the Wright brothers, to a weird extent, kind of had like the homebrew computer of the time at their house.
Right. And so the sort of picture that emerges from the historical record is these two inseparable guys, right? Like they eat together, they live together, they work together, they never marry. They also like share a bank account. So you get this great like picture of these two guys that just have this like deep, intimate, collaborative relationship over their entire lives. And, you know, the two of them, when we find them here, when we start the story, is that they are in the process of running a bike shop. And the reason they're in this business is basically because Orville is kind of interested in machines and design. And I think, Craig, you pointed this out to me, is that it's so funny because it's like, imagine if your local hometown barista wakes up one morning and is like, I'm going to invent a totally different category of transportation all of a sudden. Like, that's kind of the sort of situation that we're talking about here.
And then they do it.
And then they do it. Yeah, exactly. Right.
Yeah. But yeah, despite all of the positive circumstances of their youth, you know, like supportive family, innovative town, we should make it clear that they don't have the cards stacked in their favor, right? So on the plus side, they have a nice little business, this bike shop that throws off some money, which is great. But things that they don't have include no college education, no technical training, no experience working with anyone else, which, to be clear, they won't really do for the entirety of their careers. No friends in high places or financial backers, no government subsidies, which Langley is all about, and not all that much money saved up to just kind of like fritter around and invent things.
Yeah, not only this, I mean, I think the one thing I'd add to that list is that also these guys are like not experts in aerodynamics or anything. Like at the point at which they get interested in the problem, they don't know anything about flying. And in fact, they get interested in the problem basically by accident. So Wilbur growing up is this like star athlete. He's like great at football, skating, gymnastics. He's a top student. People think he's like destined to go to Yale, right? Yeah. Like a preeminent educational institution. And that's not to be. So when he's young, he gets into this fight on a hockey rink, and he gets his face smashed in, basically, right? And this changes the course of his entire life. So rather than, you know, kind of like college boy, you know, soccer jock, you know, kind of going off to college, he ends up being kind of a recluse, right? He has excruciating pain recovering from the injury. He has deep spells of depression, and he, basically stays at home. And he spends a lot of time kind of taking care of his ailing mother. Now, one of the interesting kind of weird anecdotes about this that I just have to tell is that the guy who beats him up is this guy, Oliver Haw, who turns out to be one of the most notorious serial killers in Ohio history. But that's like another story for another day. It's just like
fun
super
fact.
Weird. Yeah, fun fact. Yeah.
But then interestingly, Orville catches typhoid in 1896, and Wilbur's going to stay home again for this long period, and he's going to read to Orville, right? Interestingly, he doesn't just read about birds, which they're mutually into. He reads about aeronautics, specifically Otto Lilienthal, the creator of some of the most successful gliders in the history of humanity up to this point. And so Lilienthal is a German engineer and inventor, and he's building fixed-wing gliders.
Yeah, and the best part about this is that, Wilbur's getting more and more excited about this guy, Otto Lilienthal. He's got these highly publicized, documented glider flights that are happening in Germany. But as far as inspiration goes, it's kind of bad inspiration, right? Because at the point at which Wilbur is like reading about Lilienthal to Orville, Lilienthal has died, basically. In 1896, he dies in a glider crash. He's basically in a glider. There's a gust of wind. He plummets 50 feet, breaks his neck, and he dies the next day. But no matter. Wilbur's like totally captured by the work of this guy. He goes on a tear reading books about flight. And as far as I can tell, he basically goes to Orville and is like, yo, dude, when you recover, what we need to do is build one of these flying machines. And the two of them get excited about it. And, when Orville recovers, they start that project.
But they live in Dayton, Ohio. So what do you do in 1896 when you want to learn anything?
These guys start in kind of the most naive way possible, right? Which is that they write a letter to the Smithsonian Institution. Wilbur writes a letter in 1899 where he basically says something to the effect of, I'm this guy who's working on this flying machine. I'm a serious guy. You should know that. But I want you to send me some recommendations of things I could be reading if I were trying to build a flying machine. And because this is the way the government worked back then, the Smithsonian wrote back with a set of book recommendations. And they basically get to doing their research. And their initial goal is that they really want to build what Lilienthal was working on, right? And so the way to think about this is it's kind of like a glorified hang glider, right? Like that it is this fixed wing craft, no engine, nothing like that. And you're basically using the wind like a kite to get up into the air.
Yeah.
And that's their initial project.
Yeah, exactly. And so I think it's important to understand kind of the steps in how these things got built. The first things were kites. They weren't on them, right? So they're kind of controlling them from the ground. But they realized quite quickly that they really weren't able to manipulate it to the degree that they would need to if they were in it. And so it kind of leads them both through experiment and researching birds to notice that they need to be able to shape the wings rather than rotate the entire plane. And so this is the first kind of breakthrough they have, which is called wing warping. And kind of an easy way to understand this is imagine you're taking off, you're in New York City and you're like, all right, I need to fly to London. So you're taking off on a northernly facing runway and you take off and you're like, okay, everyone on the plane, run to the right of the plane. And then the plane banks to the right. Obviously, this is not how planes work. So the Wright brothers figured this out just through experimentation and observation and start manipulating their kite with little strings that shape the entire plane.
Yeah, and I think it already reveals some of what's different about the Wright brothers case and really the kind of case of flying. When we talked about the Manhattan Project in episode 1, right, it was almost like a long period of planning. They did some small tests, but really it all kind of culminates in the Trinity explosion, right, where you're like, okay, we've got all this uranium together. We're going to push the button. We're going to see what happens. And that's kind of a form of, what you might think of as like one-shot innovation, right? Is like you get one big shot to get it to work. And what's interesting about the Wright brothers is that how they get to wing warping is almost kind of like this form of multi-shot experimentation, right? They're like observing what birds do, and they're sending kites up into the air in Dayton. And they're kind of continuously sort of like learning and tweaking as they go. And that's how they come to a conclusion that, look, what you really need to do in order to get this to work is for the wings to actually change their shape, which I think is a really big deal. And you can almost kind of chalk it down to, I think, like the fact that these guys are running a bike shop, right? That they're not, by and large, like scientists in a lab writing on a chalkboard or anything like that. These are guys that like people are bringing their bikes in being like the chain is broken or something like that. And they have to like fix it. And so they're really kind of hands-on guys, which I think ends up really giving them a huge advantage, right? Like you talked about earlier, like Langley is not a pilot, right? He builds this thing and he's like, okay, now someone else is going to get up into that plane. And I think what's so exciting and interesting about the Wright brothers in contrast is that like they're okay being out there in the field.
And it's a lot of this like, let's solve the pressing problem now. Because it's not just that they're in the bike shop, like fixing chains and flat tires. They're also competing in this industry. Like bikes, for context again, like bikes were new. Bikes were like a cool thing. And they were making custom bikes. So they're like, which I guess weren't called custom bikes at the time. They were just called bikes. And they were competing with other bike shops who made bikes. So they had this like very mechanically, very like incremental innovation mindset when it came to these mechanical objects. And that's sort of how they treated these planes. Whereas, yeah, you have like the Langleys, you have other people doing these like big one-shot efforts, where the Wright brothers realized quite early on, they're like, oh, we can't really steer this kite. How do we fix that? And that's what they work on. And like each step through this story, as we're going to see, that's how it worked. And that's how they ended up kind of getting ahead in terms of their competition.
I was really amazed doing some of the research here in just how quickly the Wright brothers are able to get themselves in the air, right? Craig, like you mentioned, their initial versions are basically like flying a kite, right? This is like the way they do sort of unmanned craft to understand the dynamics. And that starts in 1899, but by 1900, they're already ready to like get one of them into the plane and like get up into the air. And so, again, right, like they're like, okay, so we've built this thing. We know it kind of works. What we need, because it's basically a glorified kite, is that we need a big area without a whole lot of rain or inclement weather, and we need a place with sufficient wind, right? But not too much wind, right? Exactly. We need something precisely between like 15 miles an hour to 30 miles an hour consistently. Yeah. You don't get that in Dayton. Yeah. And so how do you find that kind of place? Well, you write a letter, basically, right? Like, so the Wright brothers write a letter to the U.S. Weather Bureau saying, look, I'm working on a flying machine. I'm a serious guy working on a flying machine. Could you give me some data about where winds are good around me? And because this is where we are in sort of American history, the Wright brothers get a response back from the Weather Bureau saying, look, we've run the numbers, and there's this remote spot on the outer banks of North Carolina called Kitty Hawk. And you should go there because it's where you'll see the wind velocities that you're looking for. And they make the trip. And this is actually a wild thing to consider because it's not like they can't fly on a plane. Planes don't exist yet, right? And so Kitty Hawk is located about 700 miles from Dayton, Ohio, and it's the farthest they've ever been from home. The last trip I think they took that was the farthest was Chicago. Right. So this is like a long way away for them to go. And Kitty Hawk at the time is like, at least the way it's described in some of the research that we did, is like a pretty rural area, right? Yeah. There's like a couple of houses. Most people kind of are subsistence farmers and like they do hunting to feed themselves. This is not like a comfortable place to live. And they camp out. They literally camp out on a hill to start doing their tests.
And there are photos of this. You can kind of see there. I mean, it sort of, I don't know, have you seen the show Deadwood? It like has that kind of feeling. And so for me, this is another important point about the Wright brothers and their dedication to working on this. They're literally like, they kind of like fish where the fish are. They want to go to the exact opportune location to kind of get the reps in. Because an interesting fact that they discovered in their research about Lilienthal is over the course of Lilienthal's career, he was only in the air for 5 hours. Like in aggregate, all of the flights, all of the glides up until he falls out of the air and breaks his spine and dies, 5 hours. So the Wright brothers are like, we need to get way more reps in than that.
Yeah, and I think it's like two things there. I mean, one of them is, the degree to which they're okay with just physical discomfort. Yeah. And like not every scientist, innovator is down for that. Yeah. Right? Like you kind of think about like, okay, some of the people that we talked about on the Manhattan Project episode, or even kind of like the innovators that we have of today, right? Like, I don't know, like, does Elon Musk strike you as the kind of guy who's going to go out there to the middle of nowhere where no one's paying attention to him and just like tinker away on this project for months and months? I personally don't think so, right? Like, and like, those are actually distinct types of people working on technology, right? Like the class of people who are okay with like, just like eating dirt basically for months on end, trying this thing out, versus the ones that like want to do their innovation in more comfortable settings ultimately. Right?
Yeah, it's like this different type of kind of explorer, athlete, inventor. It's like it would be sort of like Shackleton-esque, right? So he's like both wants to build his boat and then also go to the South Pole. Or like if Elon Musk was like, I'm also going to pilot the first spaceship to Mars. right. It's like that kind of thing.
Yeah, and it kind of goes to what it is that you're building, right? Like, I don't think you get better results because you're like crushing code out in the middle of the desert, right? But like, you definitely get better results if you're trying to figure out how to fly.
If you're willing to crash more.
That's right. Yeah.
And then the very important point with Kitty Hawk, which is like a contrast with Langley and a lot of other people, is they want to be in the place where they can test all the time without distraction.
Yeah, and this is the wild thing is, so you gave that stat about Lilienthal kind of having 5 hours logged in his entire sort of flying career. It turns out that wing warping and the kite designs that the Wright brothers have come up with actually allow them to spend a lot of time in the air. So around mid-October of 1900, they are spending 2 or 4 hours each day gliding in the air, right? And this is a really, really important point and something that's really interesting in thinking about why, the invention of flight is different from something like the Manhattan Project, is there's this really interesting dynamic where the Wright brothers are able to get themselves in the air. And, one of the big issues with flying is no one knows how to fly because no one's ever done it before. Yeah. But they are logging more hours than anyone else, which gives them a lot of insight about how to improve their sort of flight craft, right? Like their airplane, to allow them to spend even more time in the air, right? And so they're almost kind of being able to like have this accelerating flywheel where, they create an innovation, it gives them more experience, which gives them more insight that allows them to improve the plane again and then spend more time in the air. Yeah. And that actually becomes this accelerating thing where they start to understand this problem way better than anyone else. And they get ahead of a lot of people who are sort of a lot more well-resourced in the game.
They're simultaneously developing the device and the skill set, which is kind of what other people don't have the advantage of. And I kind of wonder, I don't know if there are any stories of Wright brothers flying other people's planes, but I do wonder sometimes, like, if you just put them in someone else's plane, could they be better pilots? I don't know.
Yeah, and it looks like, and if it's worth remembering, at this phase, it really is kind of more of a craft piece. It's actually bespoke, right? Like they're building a plane for them. It's not like something that they're building for like mass production at the moment. And so I think there is kind of this interesting dynamic, which will become actually really relevant later.
And one of the funny anecdotes of these first tests, so for context, like they've now switched from kite to manned glider, right? So they're like lying down prone as opposed to Lilienthal, who was sort of like dangling out of his glider. And one of the funny stories is they like continue to be obsessed with birds. And there's a great anecdote where they're kind of just like, you imagine this in the movie, right? They're standing on the beach watching birds and kind of like flapping their arms to understand how the birds work. It's just kind of a hilarious story, but ends up being really important because they take a lot of their inspiration for the design of their early gliders and planes from birds.
So by mid-October, they've done a whole series of flights at Kitty Hawk and they go home. And so we're done. Actually, that's it. That's the episode.
That's it.
We're finished. Yeah, they figured it out. Kitty Hawk, they did the flight. Great.
Sweet.
Yeah. I mean, this is kind of the funny thing, right? Is that, the Wright brothers started their work in 1899. By 1900s, they're up in the air and zooming around at Kitty Hawk. Like, not that hard, right? Yeah. But I think what's interesting here is this is actually just the beginning of the story, right? That it turns out that it's actually fairly easy to get yourself up in the air. What's really hard is actually learning to fly, which is a totally different thing from getting yourself up in the air. And that's what we're going to talk about next.
Okay, so basically, Kitty Hawk was a total success, but they were crashing all of the time. So they were nosing or they were stalling, nosing being kind of like smashing directly into the sand nose first of your glider, or stalling, you get a stronger gust of wind and you get pulled up higher into the air. And usually you don't have control of your glider at this point. And so you kind of drop, you free fall. And that's actually what ended up killing Lilienthal. So Lilienthal got like a big gust of wind, goes up, 50 feet in the air, falls directly down. His landing gear are his legs, and he breaks his spine and dies.
Yeah, and there's a lot that we can credit the Wright brothers with, but I think we can't forget the influence of luck in their success, right? Because I think one of the things that you have in this story is that the Wright brothers just keep crashing year after year after year, and they largely kind of walk away unharmed by and large. It's scary, but like you could imagine an alternative history where like they just die on a crash, right? And like they never get to where they're going. And I think that, the fact that they are involved in all these crashes and walk away is weirdly kind of like a big feature of like why they're able to finally reach that milestone of like controlled manned flight.
So they have to figure out a way to test more often now that they're not at Kitty Hawk. They can do little things in Dayton, but it's not really the degree of like the fidelity that they need. And what do? They create one of the very first wind tunnels, which is super, super cool. And so basically what this new wind tunnel is going to let them do is test new wing shapes. And so the wing shapes are going to vary in various degrees. They're going to have different aspect ratios. So the aspect ratio is the width and the depth of your wing. You can kind of think about it like a movie picture. Like you have a 16:9 aspect ratio with a movie, same deal with a wing. And different curves, so different cambers on your wing. You have the curve on the top and you have the curve on the bottom, all of which are going to create different degrees of lift. And so in this equation, there's a very important coefficient that kind of gets multiplied by everything called the Smeaton coefficient, which everyone was using at the time. There's a fixed number. You can kind of think about it as like we would use pi to calculate in various equations. The Smeaton coefficient is used when calculating lift. The Wright brothers keep doing these tests with different kinds of wings, And then they go out in the field and are trying different things with their kites. And they're like, this isn't working. What's wrong? They realize that maybe the Smeaton coefficient is wrong. And that turns out to be the case. So they start tweaking the Smeaton coefficient. They land on a number that starts providing them actual results that match the wind tunnel and the tests. And this is a huge unlock for them. So by being able to do all these wind tunnel tests with different wing shapes, different aspect ratios, they create a model that actually gives them the lift that they need.
This is such an important point because, as we said before, right, like no one knows how to fly at this point in time, right? And, the numbers that the Wright brothers originally rely on to try to adjust and deal with the problem of nosing and stalling are these numbers that are provided by Lilienthal, right? The kind of like the guy who's logged 5 hours. He's the kind of considered the like leader in the field. I think it just goes to show the degree to which some of these places and some of these kind of technical areas are kind of shaped by hearsay and kind of cargo cults early on, right? Like everybody was relying on Lilienthal's numbers because Lilienthal was the guy and he had logged the most hours, right? He was up there flying in the air. Why shouldn't we trust him? And almost the way to think about, the kind of wind tunnel that the Wright brothers built is that they've kind of built an analog simulator. We talked a little bit earlier about the fact that the Wright brothers' key to their success is that they're able to just spend more time in the air than everybody else. That gives them a lot more knowledge on how to advance the problem another phase. And effectively, that's kind of what they're doing with the wind tunnel again, right? It allows them to test a lot of different wing shapes simultaneously without having to haul ass out to Kitty Hawk, right? And again, it kind of increases their rate of learning in a way that gives them a huge advantage.
It really is such a huge point that no one else is doing at the time. They all were just looking at historical examples and testing wide ranges in crazy ideas. Like you had things with 7 wings, 8 wings, all sorts of different shapes. You had biplanes, you had fixed wing gliders, so all of this stuff. Meanwhile, the Wright brothers are looking at birds, doing their little wind tunnel and being like, oh, maybe it's a different shape, just a slightly different curve on the top. Like again, the camber on the top of the wing ends up being super important, right? And the different aspect ratios. And all of these tests allows them to just learn more, learn faster, and learn way cheaper than everyone else.
The word starts to get out about this. I think one of the best little anecdotes from this period in the Wright brothers' work is that Langley, who we talked about earlier, right, big respected scientist, kind of slides into the Wright brothers' DMs in some ways and is like, hey guys, I hear you guys, have some, advantages with your special curved surfaces. Could you let me in on the secret? And the Wright brothers are like, no, they just don't respond at all. And so, even within kind of the cohort, this very narrow, eccentric cohort of people working on things that fly, their discoveries are starting to become more widely recognized.
Which I think is a funny contrast between the popular image of the Wright brothers, definitely in McCullough's book and at the time, is oh, these hometown heroes, they're really sweet, they're very kind, they're kind of all-American boys. They were pretty secretive.
Yeah. And I think in some ways you could argue that that's also one of the features of their success maybe, right? Is that they're secretive and highly insular. On one hand, that provides a disadvantage to other people trying to get in and copy what they're doing. It also gives them a lot of focus, right? You kind of get the sense in this period that it's the 2 Wright brothers, their assistants, but we're talking about a grand total of 5-6 people that are at the core of this project. This is not, this 100-person operation that has a lot of players.
Totally. And now is the point where we're okay, we have a new design, let's demo it. So we load up the crates, put it on a train, put the crates on a boat, take it to Kitty Hawk and test it out.
Yeah.
And it works.
Yeah, the results are good. So they, by 1901, resolve a lot of the kind of sort of nosing and stalling issues, which is huge, right? Because I think the first thing you need to solve when you get up in the air is how do you control yourself in the air? And I think this kind of jump really kind of marks their crossing of that threshold. Yeah. Now, of course, let's just recognize they're still crashing all the time, right? So during this trip, Orville loses control, crashes into the ground. Again, they walk away, right, unharmed. And, in some ways, their learning to crash is also probably an important part of their insight into what goes right and what goes wrong. They just happen to have to literally put their necks on the line to figure that out.
And again, it's it's both the machine and the skill. So you can kind of imagine that they're starting to get the idea of finesse here. They can feel why I don't quite have the purchase on this thing that I need to have. But again, it is working. Like at Kitty Hawk, it's taking off. It has the lift. And so they say, okay, well, now we need to switch over to a powered glider.
Okay, so this has been like a lot of material. I got confused myself. It's probably worth just quickly reviewing where we are to date, right? So Kitty Hawk 1900, the Wright brothers have figured out wing warping. They can actually get a guy up in the air. Huge milestone, right? 1901, 1902, they're basically figuring out the Smeaton coefficient. They're realizing that Lilienthal's numbers are wrong. They build the wind tunnel, right? And so they do these tests, and at the end of 1902, they realize that they can get up in the air, and they can also control themselves in the air. Important for flying, right? Yeah. And so finally, the big question that gets asked is, okay, so you can do all these things. You can get up in the air as a person. You can control yourself in the air. Like, how do you stay in the air, right? Particularly in a world where you're going to be flying in places that don't have consistent 15-mile an hour winds, 30-mile-an-hour winds.
Yeah, and to be clear, this is not takeoff, which is going to be a separate problem. This is literally, you're up, how do you stay in the air?
Yeah. And the obvious answer to this question is a motor, right? You put some energy into the plane so you can stay up in the air. And the Wright brothers do exactly what they always have done, right? Which is that they write to some people who build automobile engines. And the letters read exactly as they have been for the last few years where they've been working on the project. Hi, I'm the Wright brothers. I'm working on an important, serious project. I'm not a crank, but I need to build a flying machine. And what I need you to do is sell me an engine. And basically, they get no response. There's one company that basically writes them back, but the engine is too heavy. Right. And this is actually a really important point, is that you're not just looking for an engine. You're looking for an engine that's light enough and powerful enough to work on a plane. Engine too heavy, you can't get the plane in the air. And that's actually one really big problem. So they kind of do what any sane person would do, I guess, which is that they just build an engine by themselves in a few weeks, which I guess you can just do. And they work with one of their assistants by the name of Charlie Taylor.
So Charlie Taylor is a very important character in this study. So not only is he incredibly mechanically inclined, he in large part builds the engine for them. He also mans the bike shop when they're gone. Like, he is kind of the generator of income to sustain this whole project, right? And okay, so Charlie Taylor's going to build this engine. He's going to build the engine block out of aluminum. So this is one of the first aluminum engine blocks. And then he's going to kind of compile all of these other components that are sort of like the OEM equivalent at the time. And this is kind of the opening question of like, why now? Like, why do the Wright brothers succeed at this particular time? And in many ways, it's because of the internal combustion gasoline engine that was created. So it kind of is first created in 1876 when you would get gasoline from your local apothecary to literally rub on your skin as an ointment, which is funny to think about. But it's also then iterated on in the after 25 years of innovation to create something that has enough torque, horsepower, and RPMs to create an engine for a plane.
This goes to the point of the Wright brothers kind of being in the right place at the right time, right? That like, had they tried to do this project 20 years before, they would not have had access to an engine of this kind, right? The technology wouldn't have been mature enough. The engine would not have been powerful enough. And the engine wouldn't have been light enough, right? And it's only at this point in time that there's a combination of like materials science, the combustion engine, and frankly, like the economy with which to obtain these parts, that they're actually able to just assemble this in the workshop. And some of the stories here are wild. It's basically like Charlie Taylor is given just these sketches by the Wright brothers being like, build something like this. Yeah. And Charlie Taylor's only experience to date before building an engine is looking at one in an automobile a few years before, but he's like, okay, sure, I'll build it. And it works, which is incredible.
Yeah, it's super cool. Yeah, so it's like in any other time, like maybe they could have pulled off the glider, maybe. Mm-hmm. They still drew inspiration from Lilienthal, but they really, really succeeded because it was this particular time in the world and they pulled it all together.
So you've got this engine now. You've like put it on the plane. And then the way I imagine is that like they're sitting in the workshop above their bike shop. They've like installed this engine. They're like, sweet, we've got this engine now. But then like an engine is an engine, right? You need to actually like push the force of the engine, the energy of the engine in a direction. So they got to figure out a whole nother engineering problem to figure that out.
So this is the introduction of the propeller. Right. And where do we know propellers from? boats. Except, oh wait, it's totally different. Surprise. So yeah, the context is like, think about a giant propeller on the back of a Titanic, like literally the Titanic steamship, massive, I don't even know how big they are, like tens of feet long, right? So we need to shrink this thing down. We need to make it super light. And actually we're going to put 2 of them on the glider. So the propellers are going to spin in opposite directions to control the force of rotation. But they also don't even know what shape to put these things in. So they put these things in the wind tunnel and try and test it out, but kind of quickly realize that there are so many forces going on. So both the spinning of the propeller, but it's also moving through air, that they kind of land on something, but then they just got to test it.
This is actually a really interesting point is, a little bit earlier, I kind of pitched it like, okay, 1900, they solved this problem. 1901, 1902, they solved this problem. But what's interesting is that an airplane is a dynamic system, right? You imagine taking this craft, you put the engine on it, which really raises the weight all of a sudden. And then you're going to stick these propellers on. Like everything else in the plane needs to move around. All of the dynamics of the wing need to change. So they're constantly sort of like iterating to kind of fix earlier problems, even as they're solving like the bigger problems moving forwards.
But they understand the early problems, which is like a lot of the other people at the time are just like using Lego blocks of previous inventors who sort of kind of understood things. The Wright brothers actually understand the lift calculation now. So they can say like, oh, our plane weighs twice as much or more than twice as much with the engine. How do we factor that into the wing shape and wing design? And they're like, okay, no problem. We got this.
One framing that I thought was maybe kind of funny here was like, kind of we're asking the question of, like, when does throwing spaghetti at a wall actually work? And then when is it actually just like when is it a dumb idea? Yeah. Because, to go to the propeller point, right? There's people who are like, boats have propellers and it like helps them move through the water. What we'll do is we'll literally just take a boat propeller and put it on, right? And there's a lot of stuff that's a little bit like that in the early history of aviation, which is this kind of this weird cargo culty thing where people were like, I don't know, what's great? Wings. Like, it'll be even better, more wings, right? And it's just like kind of this weird, it is kind of launch and iterate, but in a way that gets you nowhere. Yeah. But similarly, I think like frequently the Wright brothers are also throwing spaghetti at the wall, but they're able to get consistent results in part because it's kind of like this like concentrated iterative exploration, right? Where they're like, okay, we're solving this problem now and we're going to run maybe 200 different wings, but then we're using that to constantly kind of improve the design. And so they're able to kind of like figure out this problem in a slow way versus trying to just kind of leap to the end, which you get like a sense of from some of these projects like Langley's project, right? Which is like, we figured out how to work it on the small level. We're going to just make a huge version and of course it's going to fly, right? That's kind of an attempt to skip from A to B. But because you skip there, you have none of the understanding that's necessary to actually solve this problem.
Which ends up being like, that scaling thing is a problem for tons of inventors at the time. They build these like torsion model rubber band test planes, and then they just scale it up to like 100x.
Right. It's like, what's great? Rubber bands. What's even better? A bigger rubber band.
And lots of them.
Right.
Yeah. And I think like the varying failures made it unclear as to what the success path would be. So like, if you have a wind speed of 30, 40, 50 miles an hour and you have like 7 wings and you just launch this kite off the side of a cliff, you're like, oh, it kind of worked. Maybe that will be the path. And so that's what sort of allowed people to have many concurrent ideas around success, none of which worked.
And there's something there about kind of what you could call like the surface of innovation here. Is like what's tricky about flying is that you have a lot of designs that kind of work, right? So if you're from the point of view of like, okay, I'm in the 1900s and I'm like trying to figure out like what plane design I should go with, like a lot of them seem pretty good, right? Because like actually there's a lot of things that you can put on a plane and still glide kind of a distance before you crash into the water and almost kill your pilot. And I think that actually makes it really difficult for the space to kind of optimize on any one design over time. And so I think what's interesting here is the Wright brothers' kind of dedication to saying, okay, there's one design, we're going to just keep pushing it down the line and get better and better year over year over year. That adds up over time for them.
And so now we're at like 1902, 1903, this thing starts to resemble what we might consider a plane, right? So it's got the wings, it's got the propellers, it's got the engine, it's got a seated pilot, and it also has like the rudder in the back, which is going to allow for more stability and more control, and it's got wing warping. And all of these things kind of add up to the 1903 Kitty Hawk flyer design.
But we got one other thing, and Craig, I'll give you the honors to talk about this, because you showed me the video and it's like hilarious. It's like, okay, so we've talked about like getting in the air, staying in the air, controlling yourself in the air, keeping yourself in the air. But there's this question of like, how do you get up into the air? And like the solution they land on is, well, you should just tell. It's so good.
It's amazing. So maybe if the wind was strong enough all the time, all over the world, we could take this thing off, but it's not. So we need a launching system, which is basically a catapult. So, so you can kind of imagine it working like this. So you have a tower, and in the tower is a pulley system. You use the pulley system to lift up, I think it's about 1,600 pounds of just weight, just like steel weight. It's pulleyed up, and then the pulley is routed out of this weight tower to another pulley down in a field. And so you back up your plane as close as you can to the weight tower. The pulley has a rope that runs through it into the field and then back to the weight tower. You attach it to the front of the plane, and then you get in your plane and you have someone controlling when that weight is going to drop. And you're like, okay, start the engines. You start the engine and you give a guy a thumbs up, and then you drop the weight. And that's how they're going to launch this thing.
Yeah, and I don't want to overbuild it. Is like, we've been talking a lot about like the Wright brothers is like, you know, they're building these craft tools for themselves. They're also just kind of pragmatists. Like, you look at this launching system and you're like, how do we launch a plane? I don't know. It's a big weight. That's a catapult that just gets the plane up in the air. Like, it's very crude, but like it totally works.
Which is kind of funny because like, it is also what Langley and other people did to launch their planes. Like, they had catapults.
Right.
Like that was like not the thing that was a real innovation, I suppose, for the Wright brothers. And it's like very crude, but sort of hilarious. But yeah, so anyway, so all of these things kind of coalesce and come together for the 1903 Kitty Hawk season. So we've put together all of these iterations. We've tested in the wind tunnel. We have a notion of how the propellers might work, how the power might come from the engine through a propeller shaft to the propellers. We're ready to try this out at Kitty Hawk.
Right. And this is the Kitty Hawk flight that you were taught about in school and know about, right? 1903, the Kitty Hawk flight. This is the first ever flight where there's a piloted machine. It takes off under its own power. It goes forwards with no loss of speed, and then it lands at a point higher than where it got started, right?
In other words, you're actually flying.
Like actually controlled flight, right?
Not just like crashing.
Yeah, we finally transitioned from the world of like getting up into the air to like actually flying. Mm-hmm. And it's so funny, when we were doing research on this episode, I just like was going off of what I kind of like learned through osmosis about Kitty Hawk. And I guess I had sort of this vision where like, you know, they wheel out the plane and then they like, you know, they set everything and then they get up into the air and they do the flight. And if you've been listening to us for the last however long it's been, right, you know that this story is all wrong, right? That like, in fact, we think about Kitty Hawk as like this moment in time, like they achieve this milestone. Yeah. And it's true. This is the first time they do all the things that I just mentioned. But look, they've been in Kitty Hawk 1902, 1901, 1900, right? Like we should think about Kitty Hawk more as like a period of time more than a single moment that occurred. Yeah. And really what you should think about 1903 as is kind of the culmination of all of the solutions on these engineering problems over time, all kind of coming together. Really what has happened is not that they've solved flight, but really more that they're just succeeding more than they fail. The first flyer is actually used in this test and never used again because it crashes actually soon after their first successful flight. And it's just like completely totaled.
Well, and that is after it's gotten off in the air, right? So like things are breaking as they're like starting up the engine and getting this all going. Like the propeller shafts are breaking, the propellers aren't working. They have to write back to Charlie Taylor and be like, hey man, we need to fix all of this stuff. Charlie Taylor's shipping things back to them.
He's like this overworked guy being like,
it's like, just to be clear, like this guy's still doing the bike shop. Exactly. He's doing all of that. And like these guys are just working out on the beach.
Some guy in the front office asking about this fixie. I just like, I gotta get this done, man.
Yeah, exactly. And so like, and then all of the time they're like, they need to cooperate with the weather too and like make sure that all works at Kitty Hawk. But All that said, they finally piece it together. They figure out the new propeller shape, the new propeller shaft. They got the engine working after the engine stops braking. And like this sets them up for the December Kitty Hawk flights.
Right. And they do it, right? They achieved the milestone. This is it. We've reached it.
This is it. Totally. And like, let's not forget, this is also when Langley is crashing into the Potomac.
Right.
Or rather, not Langley. The pilot Langley pays.
That's right. Exactly. That same month, basically.
Yeah, that same month. Yeah.
Throughout this episode, I think you and I have been doing a pretty good job, like almost downplaying like Kitty Hawk 1903. But I'm going to just take a moment to like push back on the other side, right? Yeah. Like it's a huge deal what they just did. No one else has ever done that before. And, you know, even though they are simply succeeding more than they fail, like they return home to Dayton and there's these great moments where like they're doing these demos for friends, they're doing figure eights in the air, like they've got this. Yeah. And to take another step back, like they're on the precipice of completely being at the center of a massive new industry, right? Like an entirely new category of transportation. It's going to reshape how people get around. It's going to reshape warfare. It's going to reshape everything, right? And this is a huge, not just technical achievement, but a potential like massive business opportunity.
Oh my gosh.
Yeah, and they could be at the center of it, right? They're the only people who know how to do this. Like Langley, all those other guys we've been talking about, they're miles behind. Yeah. Actually, it takes a while for anyone else to kind of figure out what they figured out.
They're at this point where they're like years ahead of folks who don't even realize that the Wright brothers have figured it out.
Right.
Yeah.
And so this is almost like the best possible situation you could imagine being in. Like in some ways, it's actually a great thing that no one cared about Kitty Hawk.
Yeah.
Because no one knows that they've got access to this like next generation technology. They've like jumped effectively like a decade ahead of everybody.
And they don't have to pitch people on it. You know, like how some technologists like, trust me, this is super important.
Right.
People get that flight matters.
That's right.
Like everyone wants this thing.
Yeah, there's this great moment where later the Wright brothers are demoing what they've built. And like in this really understated way, Wilbur comes out and he's like, gentlemen, I'm going to fly. Yeah. And then he hops in a plane and he like flies around. Yeah. It's like, you can see it working. Yeah. It's there. Yeah. Right. All right. So even all that though, you know, I think, Craig, what you and I talked about focusing on in the final kind of portion of this episode is the fact that this has not come to pass. Yeah. Right? Like that the Wright brothers have the opportunity to become absolute tycoons, to like patent the technology, control the technology, determine how the technology is deployed. They kind of don't.
No.
Right? And, you know, I think we talked about this for a long time. I think where we landed was that, you know, everything that we've been talking about, like the things and behavior patterns that led them to be such a success at cracking this problem that no one else could solve, are going to be exactly the same things that hold them back.
Totally.
Right. And that they can't capitalize. And what you kind of end up with is, look, obviously the Wright brothers do pretty well for themselves, right? They're not like, you know, penniless on the street, but they don't seem to ever achieve like what Kitty Hawk 1903 would have implied. Yeah. Right. That if you had someone, I don't know, like an Edison, right, or a Vanderbilt or something like that, that, you know, things could have turned out really, really differently.
Absolutely. Yeah. And so we're going to kind of take you to the point where they succeed, they demo, they show everyone eventually. But these traits of secrecy, of not wanting the press, of just like kind of not being in the scene, not having connections, it's all going to work against them. So the Wright brothers, in terms of commercializing this, like they don't have the business co-founder.
Right.
And
they're just bad. They're bad at it.
They're just bad. And actually what I think is really interesting, it almost feels like they never just crossed that hurdle of like applying their engineering practices to their business, like at all. And they flop for that reason. Like all of this stuff around like rapidly testing it, trying stuff out, like just focusing on like the short-term problem solving, none of that will come to pass. They're like all about the big mega deal. Like that's the whole thing for the Wright brothers, and they just like flub it over and over again.
Yeah. So let's start with talking a little bit about secrecy. I think it's a good place to start, right? You know, we mentioned it in passing, but it's worth kind of hammering that point home is these two guys, for the entirety of all their Kitty Hawk flights, they're essentially working with a really small team. It's the two brothers and their assistants, right? And they're really, really secret, which I think gives them a number of really good advantages, right? In the race to be the first to fly, right? On one hand, their competitors don't figure out what they've figured out, right? Like Langley writes to them being like, tell me all about your curved shapes. Yeah. And they're like, no, we don't do that, right? It also gives them a lot of focus, right? Like there's kind of small insular group working on this. They can kind of focus on just getting it done. Meanwhile, you have all these other guys, right? Like Langley. These are guys whose attention is pulled in a lot of different directions. And so like this secrecy and this insularity is arguably one of the reasons they're able to solve this problem. Yeah. But when it comes to business, like, I don't think it works. Like, there's this great story where the UK government writes to them being like, we've heard that you've solved this major technical achievement. We'd potentially like to work with you on funding and commercializing this technology. And the British government sends a guy. Let's remember, there's no plane, so this is a long trip. Yeah. The guy gets to Dayton, and the Wright brothers are like, no, you don't get to see the plane. We'll meet you and show you some photographs
at our bike shop.
Right, at our bike shop. Yeah, exactly. And that's wild, and that plays out, right? Like over and over again, is that their secrecy prevents them from really selling what they've built.
This is their reputation. So eventually they're going to go to Europe. They're like, trust me, we got this thing figured out. Just give me the money. Give me this big licensing deal. Let me sell you 50 planes to your army. Trust me. And then they don't do the demo. So again, like this secrecy of like, we want to be secret in engineering, and then we want you to come to us in Dayton, or we're going to just like write you letters about how awesome our technology is. Like they don't connect the gap, and they just say like, oh wait, okay. Where's the best place to test this thing? Kitty Hawk. Mm-hmm. Where's the best place to sell this thing? They never ask that question. Right. They're like, Dayton, Ohio. That's the place.
Yeah, I mean, because in contrast, like the aerodrome, right? Yeah. Like obviously huge failure, but that had some sales panache, right? Like that was the sales force, this dream force of its era, right? It's like, let's get the press out, let's make a big thing about it, let's do this dramatic demo. They don't have a sense of any of that theater.
No. Yeah. And so they're like writing to the military. They're like, come on, we want, like, it's interesting. Like their incentives are seemingly like they want credit for this thing for sure, which is why they keep it really secret. They don't want someone to steal it. And like second to that is like money. And then third of it, they have a certain degree of like patriotism. They're trying to get the government. They realize this thing has merit. Like they see the future. Mm-hmm. So they're writing the government. They're like, okay, the government doesn't kind of comply. And so they start, opening the funnel to the French and the English. And so what that leads to is a trip to Europe.
Yeah. And this is kind of wild. I hadn't realized until you pointed it out to me is like, okay, so they get working on this project in 1899, right? By 1903, they've cracked the problem. Yeah. And then it's not until I think like 1908 that they convince a French company to say, okay, we'll sign a contract with you guys. Like, you guys are weird and secretive, but like, it seems like you guys have really cracked something. So like, let's work together. Yeah. And what that means is that they spent more time trying to close the first sale than it took to figure out flying, right? Which is like really mind-bending. But this is a weird case where does it turn out that like actually, again, like their talents at technology don't convert?
I mean, they just kind of botch it. They have like all these half deals. There's also a deal with Germany. And yeah, the Wright brothers are wonderful and great and everything, but people start catching up to them, which presents a problem. And that gets them like more stressed out and more secretive. And so they're like, trying to get a deal set up with someone as like a sales agent, and like they're in charge of their foreign deals, and the Wright brothers still have ownership over like the US sales territory. It all just like, you just see this stuff playing out today when people are like, I have my super secret invention and I have to control it, right?
Yeah. And so they are basically eventually forced into doing a public demonstration, like to do the aerodrome Langley demo. Because the French company is like, we're not going to pay for this if you guys can't even show us that you can do it. And, again, like we talked about how far away Kitty Hawk is from Dayton. Yeah. Like we can just talk about
Le Mans, France.
How about Le Mans, France, which is where they're going to be headed in 1908 and 1909. And, and they make the trip, right? And this is actually kind of a interesting thing in two respects. I think one of them is, first, that's a long trip, right? And not only is it a long trip, by the time they ship the flyer to Le Mans, France to do this demo, the whole thing's totally busted by the time it arrives. And it's almost kind of a testament to the fact that, okay, the Wright brothers kind of suck at business, but all the while they've been trying to sell this thing, they keep tweaking, they keep iterating. And what the Wright brothers are able to do while they're there is to essentially rebuild the entire flyer in time for the demo.
Yeah, just Wilbur, actually.
Just Wilbur, right, exactly. Like one of the brothers is there. which is incredible, right? That basically really shows, again, like starting to move now from totally bespoke craft device to something that's like understood enough and reliable enough that you could start to kind of like machine parts in the field before a big demo, like when the whole thing has been totally busted. That's a huge deal.
It's a huge deal. And still, they don't trust anyone to work on it. Right. Which on one hand, you're like, okay, here's the secrecy thing again. On the other hand, it's like, hey, I might die if you don't tighten this correctly. So you know what? I'm going to do it. Right. And so Wilbur kind of develops this reputation, which is sort of seen favorably as like a master craftsman working on this thing in an airplane hangar slowly before the Le Mans demo.
Yeah, for sure. That actually points out a thing that I hadn't really thought of either, is like another feature we could think of as like a factor in the Wright brothers' success is that, unlike a lot of people, they understand every single inch of the machine. They've built it, they've iterated on it, they know every little bit of it. They also don't trust anyone to touch it, right? And so it's kind of like, again, like what they have mastery over the device, but they have no easy way to scale, kind of like, or it doesn't come natural to them in the very least.
I mean, they just fight with each other all the time. So, so the flyer that gets destroyed on its way to France, Wilbur thinks Orville didn't pack it well, and that's why it's trash. And then they start fighting with each other over that. It turns out it was the French customs agents that like opened the boxes and fucked it all
like,
up.
What the hell is this?
But no, it was, and yeah, exactly. So you can only imagine how annoying these guys were to work with. Yeah. Like they never scaled anything.
Right. So they're forced into Le Mans. They do the test, and it is a big success in the end. Yeah.
Yeah, I think the quote goes something like, "We are all children," as the French pilots would say to the Wright brothers. Because, again, there are other people testing at the time. There are other people doing demos. People have heard about the Wright brothers. They're talking a big game. So people show up for this demo. And that's the line that you mentioned, "Gentlemen, I'm going to go fly." Right. That's the demo. And he has his giant catapult launcher, and he takes off for a couple minutes. But in short order, he'll be in the air for over an hour, just like flying in front of a crowd of tens of thousands of people now, which is also kind of funny to think about. Like, what is just like watching a plane for an hour? Like, what's the equivalent of like taking out your phone in 1908 and you're like, oh, okay.
Yeah, that's kind of the like, thinking about the demo here is like a kind of funny scene.
Yeah.
Is like, okay, you did it. We get it. He's still up there. He's going to be up there for the next 45 minutes. In fact, so long as there's gasoline in that engine, he can stay up for as long as he wants. Yeah. But yeah, he nails it. And I think Le Mans really kind of unlocks the Wright brothers in some sense, right? Because they become recognized heroes for what they've done at that point. The aviators of France recognize that they've really made this huge achievement. Later actually turns out that, the contract gets signed. Wilbur starts basically signing and training new pilots. And they come back home to Dayton. And again, like at Kitty Hawk, not recognized, no one cared, right? But finally, I think they were like recognized in a big way, and there's a big parade.
And there's like this funny breakthrough for some reason in 1908 because it's just going to be Wilbur over there. So Orville also does a demo, and he actually crashes in the US. But again, like it's a real, legit demo. Finally, for some reason this took like 5 years from 1903. And this is kind of what you imagine. This is like the ticker tape parade. This is the letter from the president. This is like all of that stuff. That's 1908. That's when it all happens.
Yeah. But even here, there's signs that, the Wright brothers are not going to become like the world's like striding tycoons that they could have been. Yeah. Right. And this is partially by temperament. Right. And like I think also by choice. Yeah. So one of the news articles that covered their sort of itinerary of their day when they came back, it's hilarious because they're like, 9 a.m., like went to the parade, right? Like met the mayor, got the key to the city, right? Like 10 to noon was working in the workshop, right? Like noon to 1, like, they like oversaw like a celebratory dinner, right? Like 1 to 4, like back in the workshop, packing parts for shipment out somewhere. Like, I think you're starting to get these indications that these guys they're not sales guys, right? They just want to get the job done, which is charming on some level, but, allows other entrepreneurs to move into the space. And again, really kind of like hinders their ability to kind of convert their technology into a business, right? Which is, I think, romantic in some ways, but also I think like a missed opportunity, because you do get the sense from reading about them that they really did want to turn this into, the huge business that it could be.
As far as lessons go, one of the incentives for the Wright brothers was like, they did care a lot about the credit. Mm-hmm. Like the money was nice, but they really, really wanted the credit. Mm-hmm. And this was going to mire them for the rest of their lives. And in large part, it's because like they didn't have that extra brain cell or that business brain cell to like push it forward. Mm-hmm. Because they kept being so secretive about it. Not only did it like not unlock a lot of money for them, but they didn't have these like big public demos where everyone could point to them and be like, that was it, that was the moment. They were applying for patents and all of these things, but still they like other people were going to fight them on it. What actually ends up happening is someone kind of refabricates Langley's aerodrome and modifies it and flies it. And that's used as an argument showing that it predated their flyer, right? Turns out it wasn't the case, right? Because it was heavily modified. But all of this stuff is like the Wright brothers kind of did it to themselves.
And they're in litigation for years and years and years. And I think they ultimately win. Yeah. But again, this guy goes to show, right? Like I think like if you had a more cold-blooded businessman at the control panel, right, they would say, okay, we've secured our patent, right? Now let's go after those suckers, right? Like whoever's copying us, we're going to go after them, and we're going to use this as a way to build a business. But weirdly, the investors in the business that the Wright brothers ultimately set up are kind of chagrined because they win the patent fight, and the Wright brothers are like, we got credit for it now. Everybody knows that it's us. Anyways, we're gonna go back to work. Like I got some bikes I need to repair. Like Charlie Taylor's got some shipments we got to talk about. Yeah. Like they're not by and large saying the patent is an asset that we can use, right? To like preserve our monopoly on this product.
100%. Yeah. And there's like this period of time, like that is the time where they can cash in. Like this, like 1910 to the beginning of World War II, like that era, like because the Vanderbilts and JP Morgan, like these people are the people that invest like $1 million at the time valuation into the Wright brothers company. And the Wright brothers basically only give a shit about the credit. Like they just want the credit. So they don't like squeeze all of this out of the fruit. And then what ends up coming to pass is then when World War II when World War I happens, the government recognizes the importance of like aeronautical dominance, and they start pooling all the patents together between the companies. Mm-hmm. So they had like this super brief window where they could be like, they're the most important. And if they had done that in 1903 and brought it all to bear, it would have been huge for them. But they really don't. And then the window closes.
Mm-hmm. Yeah. And so the epilogue to this, I think, is kind of bittersweet in some ways, right? So it turns out that Wilbur dies kind of shortly thereafter. He doesn't live very long. Yeah. And Orville kind of pursues this business for a period of time, but he kind of sells it ultimately. Yeah. And he sets up a little workshop in Dayton and becomes kind of a tinkerer for the rest of his life. And he lives all the way until World War II. Yeah. Which is crazy to me because you think about like everything that happens in flight between them doing it in 1903 and World War II, right? Like even within like a few years of them signing the French contract, there's like 15 factories in and around Paris building planes, right? Like the growth of this industry is explosive in a way that, we think of as like exponential growth today. Yeah. And it's rare, right, in that period of time.
Yeah, and it's massive growth both financially, but in terms of like global recognition of how important this is, not only in terms of like military use and civilian transport, like all the stuff we think about today, but also sort of like the predecessor to the ridiculous Guinness Book of World Records stuff. Like,
yeah, it's like milestone after milestone.
I like can't encourage you enough. Like read the McCullough book. It's really great, but like definitely go to the list of firsts in aviation Wikipedia page. It's amazing. It's like first plane to crash into another plane, first plane to get shot down, first plane to like have a dog in it, like all of that stuff. It all happens in like 1910 to like 1930. People just go nuts for this stuff.
Right. And so it's kind of this great example of the technology kind of moving past the creators, right? Yeah. Like the Wright brothers figure out these problems early, but then it grows much faster. And, they don't control it. You also don't get the sense that they want to control it, really. And like, Orville ultimately, and this is such a kind of interesting note, but I think a note worth ending on, he, ends up working on a lot of different projects, but one of them actually is code breaking during World War II.
Yeah, it's super interesting. So actually the Navy is going to open up a base, like a computing base, like very early days computing, right? At the National Cash Registry. So again,
I told you, remember about the cash registers. The only reason that he's working on cracking codes in World War II is that mechanical cash registers were built prior to them being born in Dayton.
Totally. Yeah. And so you can actually look up the machine that Orville worked on to generate codes, and it looks kind of similar to a cash register, which is hilarious. But anyway, so like all of these people were working together to crack the Enigma, which is crazy. Right. So this guy that was like 1870 screwing around with like rubber band airplanes goes all the way into World War II working on like the earliest days of computers.
Yeah, and so you kind of, I don't know, you start as a tinkerer, you live as a tinkerer, and you kind of die as a tinkerer. Like I think that's kind of the story of the Wright brothers. All right, so Craig, we've been joking about this, but I think we should just do it on the air here. We were joking, a lot of podcasts, like they do, a historical thing. And at the very end, they're like, okay, so like, how good was that, right? Like between 0 and 10, how good was that? So I'm gonna ask you here, on a scale between 0 and 5 being the coolest big leap in innovation and the 0 being the worst, how would you rate Kitty Hawk 1903?
Okay. So I think the phrasing of this question is important. If we stop it at 1903, I'm going to give it 4.3.
Okay, that's strong.
It's like really great.
Because the average is only like 2.4.
Yeah, most big leaps. But I mean, here's Flight. But if we run this out, to like 1915, I think you got to take a point off of this.
Okay, all right, yeah. Because you think that, and this is actually a big thing. So you're kind of saying there that you think, as we talk about like, how big leaps happen, we also have to talk about what is a big leap.
Yeah.
And is kind of what you're saying that you think that like, it's only a big leap if you can make it real, if you can ride the wave, right? If you can run the business that becomes the core of, aviation.
I think they had this initial. So I think the reason why it matters is like the big leap actually is all of the things they did up until creating the flyer that demos at Le Mans, and which is more or less what they have at Kitty Hawk. Like they tweak it a little bit, but I think when you start looking at it, you're like, oh wow, like the wind tunnel, going to Kitty Hawk, like all of these things, like the mathematical study of like understanding what actually the Smeaton coefficient is and like what it really is.
Yeah.
That to me is huge. Like these guys are like completely untrained scientists, and they're like getting all these like first principles sort of breakthroughs, while everyone else is just sort of like mired in copycatting.
Right, it's like add another like wing.
Add another wing. Make it look like a circle. Make it look like a bat. Make it look like this. And there's like these guys are like, no, we're gonna figure this thing out.
Right.
That's amazing. I think like that's like the inventor mentality.
Sure.
And then like the huge, like almost impossible is like, oh wow, we took this to another level.
Right. Because I kind of buy that is like, it has to have some kind of impact, right? Like we can appreciate it as like an intellectual achievement, like even an engineering achievement. But like for it to be something that we think of as like a mega project in some sense, or a big leap, like it has to show, like the creator has to almost get tied into like its ultimate impact on the world, right? Like you kind of don't get to just sort of like hand it off to someone.
Yeah. What do you think are the big lessons here?
I mean, I think that, so friend of this podcast, Michael Nielsen, had a pretty good comment on our first episode, which was basically to the point that like, he was kind of like, in Silicon Valley, a lot of people were like, oh my God, the Manhattan Project. Like we love the Manhattan Project. And like, A, that's kind of weird. But then B, like, there's a lot of things about the Manhattan Project that we should think of as almost like singular in nature, like the nature of the technical problem, the situation that it's in, what they're trying to build, all those sorts of things. I think one of the lessons I take from the Wright brothers is I have this kind of suspicion that like what the Wright brothers are doing and the kind of problem they're working on is a much more common kind of problem, right? That it actually, like, if you think about like innovation or like technology, it looks a lot more like what the Wright brothers are doing 9 times out of 10 than it looks like the Manhattan Project. And so I think there's actually like, this is like a meta lesson. There's more to learn from the Wright brothers example than there might be from the Manhattan Project example. To get down into the Wright brothers example specifically is like, the other thing it makes me think about is places where sort of like physical courage or bravery is like critical to figuring out the engineering problem. That's kind of what's interesting here is that like, there's very clear examples where the Wright brothers have like disadvantages But the key advantage that lets them win, right, in the sense that they get to this milestone first, is that they're just willing to go up in the air, right? And that just takes a certain level of gut willingness to be like, yeah, I'm just going to kind of put my neck on the line. And I think there are certain problems that you can't solve without that like learned experience.
Which you could then break apart. It's like courage and almost like athletic ability. Like they have a certain predilection to be able to make this work. You know, it's like he was going to go be an athlete at Yale, right? And so clearly he transferred some of that. Wilbur transferred some of that to flying a plane.
Yeah, and I think it's kind of like the technology of, it's like this piece that often gets left out is like when you build a new technology, you're also building like the set of skills you need in order to operate the technology. And that's like almost like another set of problems outside of just solving the technical problem.
Totally.
Right?
It's
like,
the thing that makes the other thing. You know what I mean?
yeah,
like,
that's right. And even in
enables.
places where like, you know, because I would hear like, I mean, I'm just hearing like a skeptical person hearing us talk be like, well, okay, it's just because it's planes, right? Like you got to be out there flying in the air. But I'm kind of like, you know, I've been watching all this stuff with like ChatGPT, right? Super interesting. But I think one of the things is that everybody is also collectively kind of learning how to get certain things out of the system, right? Where they're like, oh, like if you ask it this question, you can get it to do this. And I think what we're seeing in real time is people like learning a set of practices around like getting the technology to do what they want. And like that's a skill, right? Like because right now we just don't, particularly for stuff like these LLMs, like we don't understand the technology so well that like we're like, oh, you know, you push button X and you get result Y. We're still in the realm of like kind of like flight, right? It's just like, I guess we'll try this. Like this has kind of worked before. Do you think that this is related to this? We're like in that more kind of like feeling around phase.
We're just screwing around. We're like figuring it out, learning how to control the thing. And when you think about it, it's like, oh, it's just a tool. And there are various uses for a tool, and there are various degrees of mastery within all of those uses. There are a lot more comparisons that come out.
Yeah. Do you think we should think about it as like a form of art, like what they're doing?
I mean, my personal interest is like, oh, this is going to be great. Yeah, like,
right,
there's
right.
like a total art form. There's an art form to creating it. There's an art form to using it, right?
One component that we can take the art direction in, which I think is the art direction in, is sort of interesting is like, you know, art is about the method of creation, but it's also kind of like the scene in which you create it, which I think is such an interesting thing because there's actually a lot of like geography in the Wright Brothers story, right? Like they're not in the capital cities of America. They're not these well-connected guys. That means they're kind of like off on their own, like being able to kind of focus on the problem, right? Kitty Hawk, right? Like they happen to be close enough to a place where it's still like they got to go out there and camp, right? It's like they can't just like easily get there, but like they happen to be in a place and they go there, and that gives them the most chances to get their plane design to work, right? And so there's a lot here about basically just like the degree to which like the conditions, the physical conditions just have to be right for you to do this sort of thing. Yeah.
But interestingly, just to stay on with the AI example for a little bit, like the Wright brothers were sort of out of the scene.
Right.
And so like will important steps in AI you think maybe come from out of the scene? I know we have the internet, so it's a little bit harder now, but like
I mean, the AI story is for me, it's a story about like being out of the scene.
Okay.
Right. Which is basically that like contemporary neural nets, deep learning, all this kind of stuff. Like we forget now just because it's like so obvious, but like was considered just this huge intellectual backwater for a long period of time. People were like, we spent money on this in the 1950s and 60s. It didn't work. We're not going to spend money on it anymore. And like essentially the people who carried the flame of kind of like contemporary neural nets were like kind of working in obscurity. They were like in these universities in Canada. They're just kind of scattered all over the place, right? And you know, it's interesting, like there is actually this very strong Wright Brothers parallel, which is that we finally got the engines, which are these like NVIDIA boards, the GPUs, right? To like actually show that like this crazy idea could actually work, right? And, you know, I think that there is some value in the idea that like this community, particularly in AI, kind of like labored in obscurity for a period of time because it allowed them to kind of work out certain types of problems. And I think that there is kind of this interesting value. Like we can think about like, what are big leaps that can only happen because you're like at the nexus of kind of like social and money and business power? And like, what are the only types of innovations or types of art that can only happen because you're like on the outside?
Where would you classify us in the Wright brothers story in relation to AI? Like, are we at the put more wings on it stage? or you think we're more in the tweaking it, kind of figuring it out stage?
Yeah, what's different, I mean, you can kind of think about AI as kind of like this weird hybrid between our first episode and our second episode in some ways, right? In the sense that basically, like, as we said before, the Wright brothers kind of they build the flyer on like $1,000 from the proceeds from their like bike shop, right? This is like low cost to entry for the technology. Okay. Manhattan Project, in contrast, is like probably like the highest cost to entry you could imagine, right? Is like, we know the cyclotron works. We need to build a city-sized series of cyclotrons to get enough uranium to blow this thing up. And I think AI is kind of this like, it's sort of this weird hybrid, right? Like in the sense that it's a situation where the resource requirements are still really, really high. Mm-hmm. So you don't really, like the Wright brothers, like the Wright brother equivalents are like very much kind of tied into like companies, like organizations that have the resources to pursue this technology, right? Like it's very difficult for like kind of like outsiders to build some of the models that are doing the really impressive things today, right? And I think that's a really interesting kind of contrast, is basically that like the fundamental nature of machine learning may lead it to have a very different contour from like trying to get flying to work.
On the other hand, we might be at the beginning of the Wikipedia page of firsts in AI.
Yeah, and I think we are getting to that phase, it feels like.
Yeah.
And actually, I mean, it's really funny. Like, I mean, one of the critiques that people have of like AI conferences, they're like, this is so boring. Like, you're like, we have this metric, and like the way you win in machine learning is like, yo, bro, I was able to optimize that metric 0.004 more than you. Like, I win. And the next year you're like, oh yeah, bro. Like, and that's actually very, very similar to like what you remarked is like the psychology of flight. Yeah. Is like, once they break this first milestone, everybody just wants to be the first at like increasingly minor, small things. Yeah. And there's something about maybe the space that kind of like lends itself towards like, you draw the line and people are just excited to cross the line arbitrarily. It's just like, just that we have a line is the important thing.
Yeah, so. Totally. Yeah, it just coalesces around these like micro little ideas. Yeah, and so I think that like going back to the silly grading system, I think the Wright brothers' failure to capitalize on this as like the important financial opportunity and the credit is by virtue of them not being in the scene. Like,
correct. Yeah, exactly. And I think kind of, I mean, you know, I do wrestle with it a little bit. It's kind of like they don't want to. Yeah. Right. And like to their credit, maybe to their credit, they don't want to. Yeah. Like, I think it's rad as hell that, you know, like Orville just is like, yep, I did the thing. Like, you know what I'm really interested in now? Cryptography. Yeah. You know, that's cool. I think that's cool, right? And I think that like we should conceive of big leaps as not necessarily needing to like have a distribution channel, right? That is an achievement in of itself, but maybe a little bit different from the kinds of things that we're talking about, right? Like I think we're still trying to find the label for the category of thing that we're talking about on the show. Definitely. But I think they, just like the first episode, it's right place, right time. For sure. Yeah, right. Like, there is a lot of luck in this story for sure. Yeah. So like the lessons are like right place, right time. They applied like way more rigorous thought to it than anyone else. They were willing to suffer for it. Like they were willing to go to Kitty Hawk when clearly like it wasn't like they had 20 other competitors hanging out at Kitty Hawk or even any other comparison to Kitty Hawk. Like it didn't exist. Like they were there. No one else was there. Yeah, right. And so they did it way faster than everyone else. Yeah. And I think there's that's kind of the ultimate lesson that I draw from it is, like kind of time on site, right? Like shots on goal. Yeah. Like they're able to get ahead because they just have more experience than everybody else. Totally. And so like one way of kind of thinking about it is like, what are the kinds of problems where in order to like get ahead, you just need to like increase the amount of experience you have per unit time. Yeah. And like whether or not you're doing that through a wind tunnel or like crashing yourself into the ground somewhere in North Carolina, like both are critical ways of doing this. I think I'm struggling to think of an example where it's not that. Yeah, that's fair. Yeah. I guess atomic bombs are an example where you're like, oh, we get one try here, but they were testing to a certain extent. It's kind of like what are problems you can creep up on, right? Like sometimes you do got to push the button, you try to send the guy to the moon, but even there, that's iterative, right? Like they basically like. They're like, let's go around the moon. Yeah. Okay, let's like touch the moon and come back. Okay, let's touch the moon and have a guy spend some time there. Like that's also iterative. Yeah, exactly. But like, each roll of the dice is way more expensive there. Yeah. And so just in closing for the episode, huge shout out goes to Buskirk, who's helping us do all the research for these stories and making it happen.
Protocol Labs, who's funding our sponsorship, making this also possible. And so for episode 3, we're going to change gears. We're kind of like, again, as Tim said, we're like finding the shape of this thing. I don't know how you feel about it.
Yeah, no, I think that's right. I think like there's something that links all these things. I think what we're on the journey of is trying to figure out like how to articulate that.
Yeah, exactly. So we're going to take a turn. And for episode 3, Las Vegas. We're building a city in the middle of the desert. It has all kinds of crazy connections. The Hoover Dam, Howard Hughes, the building a city about a sin or entertainment or whatever you want to call it. Like, it's very unique and it's totally different. And we're very excited for episode 3.